microphone on. It's funny, I might be the only person in the world who has a win-win situation when it comes to an asteroid impact. Anyway, let's start.
Scientists are closely watching a recently discovered asteroid that is being called a potential city killer.
There is a potential danger in space, and it's on a collision course with Earth.
Scientists are trying to work out whether there's a chance of it hitting the Earth.
An asteroid on a collision course to planet Earth?
An asteroid hurtling towards us is starting to look a lot more like hitting Earth.
We do have a trajectory lined up.
So if the people with the giant telescopes are telling us not to panic, should we listen?
All right, let's take a deep breath. If you've survived the headlines about Asteroid 2024 YR4, congratulations. Your news dodging reflexes are top tier. But let's be honest, trying to get actual information about an asteroid these days feels like dodging debris on the battlefield of clickbait. But don't worry, this is your bunker of clarity. In this video, I'll walk you through how astronomers actually determine impact risks, share what scientists are actually saying, and whether or not you will really need to start building that underground bunker. Spoiler alert, probably not. So let's dive into the story of 2024 YR4, how it was discovered, what its real threat level is, and what would actually happen if it ever decided to knock on Earth's door. Or the moon's. This is 2024 YR4, the city killer asteroid that had everyone talking. And I have become obsessed with this asteroid, checking its impact probability daily, learning everything I can about what would happen if it impacts on land, reading papers about what would happen if an asteroid like this were to hit the ocean, to what would happen if it hits the moon. And frankly, I'm mad at this asteroid. I am mad at this asteroid because while it caused so much drama, mostly thanks to the media, it couldn't possibly just stay on a level 3 on the Torino scale, which I'll get to and explain later. It couldn't stay there at least until I posted this video on YouTube. Like, come on. It now poses practically no threat to Earth for the foreseeable future. However, despite this, because I have sunk way too much time into learning about this chunk of space rock, I'm going to tell you everything I know about this asteroid and give you the tools you need to tackle the news of an asteroid impact the next time one comes around. Let's begin. Before we get into the nitty-gritty, the current chance of Earth impact on the 22nd of December 2032 by Asteroid 2024 YR4, as of recording this today on the 28th of February, is at 0.0011%, putting it at a level 0 on the Torino scale. However, its chance of hitting the moon on that very date has crept up to 1.7%. And I'll get into what a potential lunar impact might look like later on, so stay tuned for that. Now, onto the brain dump. Asteroid 2024 YR4 is a relatively small-sized asteroid. The average size of an asteroid in the solar system is 204 meters wide. This one is expected to be between 40 and 90 meters wide. Its orbit around the sun brings it almost as close as Venus gets to the sun and gets almost as far as about 3 times the distance Mars is from the sun. Despite its relatively close proximity to Earth for what I suspect would have been many thousands of years, if not millions, 2024 YR4 was discovered just last year, on the 27th of December in 2024. It was spotted by a telescope in Chile that makes up part of the Asteroid Terrestrial Impact Last Alert System, or ATLAS for short. ATLAS is a robotic astronomical survey that constantly monitors the skies using telescopes positioned around the world so that it gets effectively all-sky coverage. The goal of ATLAS is to spot small asteroids that are likely to cause minimal but not insignificant damage within a few weeks or even days before potential impacts. It has done this on 3 occasions out of a total of 11 instances where an asteroid was spotted before Earth impact across multiple surveys and observations. But sometimes, ATLAS finds bigger rocks hiding in plain sight, like this one. ATLAS searches for asteroids by taking photos of the sky, when it's clear, every 12 minutes, and looks for objects moving across the sky against the relatively fixed background stars and galaxies. That's how it spotted 2024 YR4. By the way, if you're wondering why this asteroid is called 2024 YR4, don't worry, because I have spent way too much of my time preparing for this video by researching this specific topic. And I think I understand it now. So 2024 YR4, what does it mean? Well, the 2024 in 2024 YR4 means it was discovered, you guessed it, in the year 2024. Seems like a no-brainer. But anyway, moving on. Now, the Y in 2024 YR4 indicates which 2 weeks of the year the asteroid was discovered in, specifically the final 2 weeks of the year between the 16th and 31st of December. By the way, the letter J is not used for this designation. Why? I don't know. I could not figure that out but I do suspect it might have something to do with astronomers using J to designate dates, as in Julian dates, but I might be wrong. But that is what I suspect. Anyway, moving on. Finally, the R4 bit in 2024 YR4 means it was the 117th asteroid discovered in those final 2 weeks of 2024. So, following this naming convention, the first asteroid to be discovered in those final 2 weeks of December would have the name 2024 YA. The second would have been named 2024 YB. The 26th would have been named 2024 YA1 because we skip J and go back to the start and add a number on it. I think. That's my interpretation, at least. And the maths out. So I'm convinced that's how it works, and I understand it now after way too long staring at the system trying to figure it out. So now that we're all caught up on the most important information about 2024 YR4, how it was named, let's get to the other important stuff. How is an impact probability determined? How do we work out if it's going to hit the Earth or not? Since its discovery, the impact probability of 2024 YR4 has jumped around quite a bit. As far as I can tell, it started off on the 27th of January with an impact probability of 1.2%. So a 1.2% chance of hitting Earth on the 22nd of December 2032. Then it rose to 1.9% by February 5th. 6 days later, it rose again to 2.3%. By February 18, it reached its highest chances of impact so far and the highest impact probability ever seen since records began of 3.1% before jumping back down to 1.5% the next day and then down to 0.28% on the 20th of February. Then it dropped dramatically to 0.005% by the 23rd of February. And now, as of filming this video on the 28th of February, the chance of impact with Earth on the 22nd of December 2032 is 0.0011%. But how do we actually get these numbers? Well, once the asteroid is officially discovered with telescopes or surveys like Atlas, a few observations over a few nights are compiled together to get an initial estimate on the orbit of the asteroid. After this, follow-up observations are crucial to improve the accuracy of the orbit. And these can be done with pretty much any telescope around the world. Even infrared telescopes like JWST can be used for this, and doing so can help us learn even more about the asteroid because measuring it with infrared light allows us to determine a more accurate estimation of its size and therefore narrow down how much impact it could potentially cause. Once the initial orbit is known, potential positions are forecast years into the future and compared to Earth's future position. Now, many simulations are run with this initial orbit calculation, but with slightly different parameters to account for uncertainties in the asteroid's orbit. Now, the percentage chance of impact is estimated based on the number of simulations that result in an impact. So, if 1,000 simulations are run and in 12 of those simulations the asteroid actually hits Earth, that means the predicted chance of impact is 1.2%. Now, a few people in the comments on my short videos about the updating impact probability have asked how can there be an uncertainty on the impact probability when that itself seems to be an uncertainty? To answer that, we need to go back to my first year physics lab notes on uncertainties. Now, in any calculation that you do, if a measurement that you're calculating has an uncertainty, that uncertainty carries through the calculation in different ways depending on how you use the measurement in your calculation. So if you start with uncertainties, you're going to end up with uncertainties too. Now, how we reduce that uncertainty on the impact probability, as well as refine the impact probability itself, is through expanding the observation arc of the asteroid. That means observing its orbit at many different stages of its orbit that cover a larger amount of the orbit. Right now, we have lots of observations of its orbit, but only really over a short time period. This asteroid takes about 4 years to orbit the sun, and we've only been watching it for barely 2 months. So as we observe it for longer in its orbit, we'll start to get more of a refined results and estimates. Oh my gosh, how many times did I say orbit in that sentence? So, based on all current data captured for this asteroid, the current probability of an Earth impact on the 22nd of December 2032 is 0.0011%. By the way, for the select few people who have left comments on my videos saying the chance of impact is actually 50-50, I hope this explanation helps you understand that yes, there are two outcomes in this scenario, hitting Earth or not hitting Earth, but while there are two outcomes, the weight of each outcome is vastly different, and one outcome is much more likely to happen. It's not a coin toss, it's much more sophisticated than that. By the way, researchers found that not even a coin toss isn't even 50-50, when in a 2023 study, these researchers flipped a coin 350,757 times and found a slight bias towards the side facing up at the time of flipping had a 51% chance of landing face up. Let's test it right now. So heads is up, and it landed up heads. Science. What can I say? That was the first time I did that as well. That is not an edit, that's not a cut, that is the first time that I did it. But throwing all these percentages around can get really confusing really quickly. Thankfully, there is a useful tool that astronomers use to rate asteroid impact risk. And it's not just a useful tool, it's a way to communicate how serious a potential collision could be. And it's called the Torino scale. Basically, it combines two key things: how likely the asteroid is to hit Earth, and how much damage it could do if it did. And instead of just throwing around percentages like candy, like I did recently in this video, of 1.2%, 1.9%, 2.3%, 3.1%, 1.5%, 0.28%, 0.005%, 0.0011%. The Torino scale simplifies everything into a color-coded system from 0 to 10. So let's break it down. Level 0, the white level, indicates no impact risk. That's where we are right now with 2024 YR4. Level 1, or green, is the normal level, which is interesting. I would have thought no hazard would be normal, but I digress. Levels 2 to 4 are the yellow levels. These are the, we should probably keep an eye on this one levels. Astronomers track these objects more closely to better quantify their probability levels, just in case. The orange levels, 5 to 7, are where things get serious. If an asteroid is in this range, it's coming uncomfortably close and it's big enough to do some real damage. At this point, mitigation planning is strongly encouraged. And the red levels, 8 to 10, are where impact is basically certain. This is the oh no zone. At level 8, we're talking local destruction or tsunamis if it hits the ocean near a coastal area. At level 9, where objects are between 100 meters and 1 kilometer wide, these could cause regional devastation if it makes impact on land, and tsunamis if it lands on the ocean. And if it's bigger than 1 kilometer in level 10, well, just ask the dinosaurs how that went for them. Now back to 2024 YR4. Because its impact probability is so low and because of its estimated size, it sits at a level 0 on the Torino scale, so the no impact likely level. However, it used to be at a level 3 because it's between 20 and 100 meters wide, currently at an estimated size of 40 to 90 meters wide, and its impact probability did fall between 1% and 99%. I know, that's wider than I expected too. Anyway, if its impact probability were to go above 99% and its size estimate stays the same, it would land in a level 8, which means we'd need to start taking serious action. So the Torino scale is a super useful tool, not just for scientists, but for all of us really, to understand how risky an asteroid actually is. And while we're no longer in the danger zone, it's always better to be prepared than surprised. Down to the question on everyone's mind, what would happen if it were to impact Earth? Even though it's definitely not going to now, let's discuss what could happen anyway so you can be well informed when the next one comes around in the news cycle. Now, what happens when an asteroid impacts Earth depends on what the asteroid is made of. So let's consider what could happen if an asteroid like 2024 YR4 were to hit Earth, because that's what I wrote about when it was at a higher chance of hitting Earth. So Well, I'm just going to tell you this one. If it's a stony asteroid, it could explode in the atmosphere, causing an airburst and a fireball strong enough to flatten a city, similar to the Tunguska event in 1908. These images are just simply incredible. It's not known exactly what object caused this event specifically. However, scientific consensus says that the explosion was caused by an airburst of a stony asteroid. Although some scientists suggest it was actually a small comet, which is kind of fun. Whatever it was estimated to have been approximately 50 to 60 meters wide, and some models suggest it could have been up to 80 meters wide. But since it left no impact crater, it's believed that it exploded in the atmosphere at an altitude of 5 to 10 kilometers rather than hitting the ground. And the explosion managed to knock over an estimated 80 million trees over an area of 2,150 square kilometers. This was an absolutely insane event. However, if it's a more metallic asteroid and mostly made of iron, that would be much worse, as it could punch through the atmosphere and leave a massive crater that would likely be about 1 kilometer across and hundreds of meters deep. Either way, it would be a very bad day for the local area, but not a global disaster. Now, if an asteroid were to impact Earth, it would most likely hit the ocean because 70% of the Earth's surface is covered in oceans. So what would happen if 2024 YR4 were to hit the ocean? Well, scientists have modeled what would happen based on if different sized asteroids were to hit the ocean in this paper from 2022. So let's go through it. Renato Moraes and friends looked at the short-term consequences of asteroid impacts into the ocean. Great title, by the way, really summarizes the study very clearly. Specifically, they looked at the consequences of an asteroid impact at the midpoint between Portugal, the Azores Islands, and the Madeira Islands. So right about here-ish. And they looked at 3 potential asteroids. One real, that being the 370-meter wide Apophis, and 2 imagined asteroids. A medium-sized asteroid at 204 meters in diameter, or a 5-kilometer diameter asteroid. Keep in mind, all of these are bigger than 2024 YR4. Now, they actually looked at all of these different consequences in their study. However, since everyone has been asking me about tsunami threats specifically, we're only going to focus on that for this video. I will put a link to the study in the description below if you want to read more about these other consequences. For now, what are the tsunami threats of these 3 potential asteroids in this specific scenario? Firstly, the study distinguishes 2 types of waves in their discussions about tsunami threats. There's the rim wave, which is the initial wave caused by the asteroid's impact on the ocean. Then there's the collapse wave. You know how when you drop a rock into water and it creates a kind of temporary dent in the water, then the water from around that temporary dent fills in the dent, but in doing so, all that water filling in the temporary dent splashes together and creates a sort of peak in the middle where the rock was dropped in the first place, and that peak falls back down and creates more ripples and more waves. That is the second type of wave that they talk about in this paper. So with that explained, let's get into the results. Starting with the smallest asteroid, the 204-meter wide asteroid. The impact of this asteroid would cause a rim wave at mainland Portugal with a height between 7.5 and 9 meters. This would result in 1.2% to 8.2% of the population of mainland Portugal being affected. Now, you might expect that the larger asteroid Apophis would have more dire consequences. And if you thought that, you'd be right. The rim wave created by Apophis impacting off the coast of Portugal would have a height between 17 and 20 meters hitting mainland Portugal. Best case scenario, that would impact 7% of the population on mainland Portugal, and the worst case scenario is up to 24%. Okay, I hope you're sitting down for the results of the 5-kilometer wide asteroid because holy moly, these numbers jump up quickly. The rim wave produced by an impact of a 5-kilometer wide asteroid would be between 350 meters tall and 420 meters tall at the coast of Portugal. This would have dire consequences. Not even more dire, just straight up dire consequences, where mainland Portugal could see 79% to 81% of its coastal population affected. Not good. So, given that 2024 YR4 is smaller than the 204-meter medium-sized asteroid impact scenario investigated in the study, If it impacted Earth in the ocean within 16 kilometers of a coastline, there would probably be a tsunami warning, but with waves shorter than 7.5 meters. For comparison, the worst tsunami in recorded history was the Boxing Day tsunami in 2004. That tsunami had waves up to 30 meters in height. Now, despite the fact that this asteroid has now got a probability that's well below 1% and it's considered no impact risk on the Torino scale with a level 0, there are still challenges ahead of us with respect to monitoring this asteroid and narrowing down its specific path, especially when it comes close to Earth on the 22nd of December in 2032. And this can be applied to similar asteroids. For example, the asteroid Apophis hasn't been observed since May 2021, and it won't be again until 2027 because it's currently very close to the position of the Sun in the sky, making it very difficult to observe. However, for 2024 YR4, it's currently moving away from Earth. And as it does this, it will become increasingly difficult to observe because it's getting fainter. As it moves further away from the Sun, it receives and reflects less light from the Sun. Also, since it's further away from Earth, it will appear fainter from our perspective as well. It's kind of like a really distant streetlight. By about April, it will be lost to even the world's largest telescopes. Thankfully, JWST is set to observe the asteroid in early March and will give it a second try in May. After that, the asteroid will likely be invisible even to JWST until the asteroid comes back around in its orbit and becomes visible again just after Apophis in 2028. Thankfully, right now, the probability of it impacting Earth in 2032 has dropped well below 1%, so we can breathe a sigh of relief for now. However, it appears that the chance of hitting the moon in 2032 has crept higher than 1%. So let's talk about that scenario. As of the 24th of February 2025, the chance of 2024 YR4 hitting the moon on the 22nd of December 2032 is at 1.7%. So what would happen if it did hit the moon, and how would it affect us? Firstly, the collision would likely be visible from Earth, which is really cool. However, don't worry, because it probably won't cause any major threat to us on Earth. There's a possibility this impact would eject some material that could hit Earth, but the pieces should be smaller than the asteroid itself, so they should be fine and just burn up in the atmosphere. What's really cool about this is that the ejected material could create a meteor shower for Earth. So this asteroid hitting the moon could give us an impromptu meteor shower. Like, that is wild to me. If the moon were to be hit by this asteroid, it would leave a crater potentially up to 2 kilometers across, which for comparison is quite small compared to the moon's largest crater, which is the South Pole Aitken Basin at 2,400 kilometers in diameter. My move. No! Oh my gosh. Stay. Oh my goodness, I'm sleeping on a blow-up bed in my study because I don't want to catch COVID from my husband, and the dead almost fell down on me. So far, I've struggled to find a place that updates the possibility of 2024 YR4 hitting the moon daily, like NASA's Sentry Risk Table and the European Space Agency's Asteroid Risk List. They update daily regarding the possibility of an Earth impact. However, occasionally, there are blog post updates on NASA's Planetary Defense blog where they share the probability of a lunar impact, so hopefully they continue to do that as the number fluctuates. From a scientific standpoint, we could do some experiments with this asteroid hitting the moon. If the asteroid were to strike the visible side of the moon, it can provide a valuable opportunity for an experiment in the conditions of the lunar crust. Specifically, if we know where it's going to impact, that would allow scientists to train appropriate sensors on the impact location to observe it happening, and the resulting data could inform our understanding of the composition and structure of the lunar crust. However, to make this a truly useful experiment, the impact location would need to be predicted within 25 kilometers of the actual impact site. Now, while we don't have to worry about this asteroid hitting the Earth anymore because its improbability with Earth has gone well below 1%, here are the ways that we could potentially move this asteroid off course, or any asteroid off course, if it were to have a certain impact with Earth. The first strategy, and probably the most well-known strategy, is the kinetic impactor. This technique involves sending a spacecraft to ram into an asteroid, thus altering its trajectory. And we've demonstrated this before on a real asteroid in space with the DART mission, the Double Asteroid Redirection Test, which successfully altered the orbit of Dimorphos, which is a small moon-ish of the asteroid Didymos, by smashing it with a spacecraft. Another potential strategy involves using a gravity tractor. This is my favorite of all time for these options because it sounds so simply ingenious to me. Basically, this method involves flying a spacecraft alongside an asteroid and using its gravitational pull to gradually alter the asteroid's path. Now remember, everything that has mass has a gravitational influence or a gravitational field around it. Some are just bigger and stronger than others. Now this next strategy will probably be liked by many because it involves lasers. This concept, called laser ablation, involves using lasers to vaporize rock on the surface of an asteroid. In doing so, it creates small plumes of ejected material that push the asteroid and change its course. Now, this hasn't been tested on an asteroid in space yet, but laboratory tests of laser ablation have shown it could be a feasible asteroid deflection technique. Then there's the ion beam shepherd, which uses an ion thruster pointed at the asteroid from a nearby spacecraft. The momentum transmitted by the ions that go out of the spacecraft and reach the asteroid's surface produces a slow but continuous force that can deflect the asteroid. And it is suspected that this method would be more effective than my favorite little gravity tractor. And if none of those options work, if worst comes to worst, then we can just nuke it. This is the last resort option. If efforts to deflect an asteroid on a collision course with Earth with the previous methods all fail, or if we didn't see an asteroid coming until it was too late, a nuclear blast could be used Armageddon style. And that's how we could protect our planet from a potential asteroid impact. I think that covers everything. Everyone has asked me about this asteroid recently, so there you go. That's everything you need to know about this once potentially hazardous asteroid, 2024 YR4. So now, the next time a potentially hazardous asteroid rolls around and has the clickbait battlefield reigniting, you'll have the knowledge and the tools at your disposal to help you understand what's really going on and critically question those often sensationalized headlines. I can't believe the bed almost fell on me.